prime numbers and number theory. Prime numbers and their properties were studied extensively by ancient Greek mathematicians. In around 200 BC, the Greek mathematician Eratosthenes devised an algorithm for calculating primes called the sieve of Eratosthenes. Euclid defined a prime as a number measured by a unit alone, a composite as a number that is not a prime, and a perfect number as one that equals the sum of its parts. Except for the number 2, all prime numbers are odd because even numbers are divisible by 2. Modern number theory is a broad subject that breaks off into subcategories, including the prime number theorem.
The prime numbers theorem, or PNT, is the most celebrated and famous result of analytic number theory and number theory. The PNT formula gives an approximate value for the numbers of primes less than or equal to any given positive real number, x. Then PNT also states that for large values of x, pi multiplied by x is equal to x divided by ln multiplied by x. The limitation for this particular equation has x being the search size. X must approach positive infinity. That means that x has to be a real number, which means no decimals, negatives, or fractions. Pi multiplied by x is an actual count of the amount of primes within the search size. X divided by ln multiplied by x is an estimate of the amount of primes within the search size. These two equations should be relatively equal to each other. Here we have our example problem of this equation. X is 100 trillion, which is going to be our search size. Remember that our limitation is x to positive infinity. X must be a real number, which means no negatives, decimals, or fractions. This equation will never actually equal 1. It is similar to end behavior, where we are always approaching 1, but never will actually meet it. Here for our example problem, we have pi multiplied by 100 trillion over 100 trillion over ln of 100 trillion equals 1. When pi is multiplied by 100 trillion, we get 3.14 multiplied by 10 to the 14th over 100 trillion over ln multiplied by 100 trillion. When ln is multiplied by 100 trillion, we get 32.23611913. Everything else from the previous step stays the same. When we have 3.14 multiplied by 10 to the 14th divided by 100 trillion, we get 3.14 over 32.23611913. When these two numbers are divided by each other, we get 0.0974060481. When this number is rounded, we get 0.1 to be equal to 1. Like I had said previously, we will never fully actually meet 1. We will only get closer to 1.
Here we have a prime numbers chart. This is only a small portion of the prime numbers in existence, as there are an infinite number of prime numbers. You may notice that 2 is the only even prime number. This is because all even numbers can be divided by 2. You may also notice that prime numbers besides 2 and 5 all end with a 1, 3, 7, or 9. You may wonder, why bother using prime numbers and learning about them? Well, prime numbers are often used in modern-day technology and physics. And number theory is also important. Number theory can be applied to numerical analysis in cryptography. Number theory is important to our world today because it helps us better comprehend the changing world around us and mathematical concepts that are frequently used.
Thanks for watching!